Okay, in the last video, I thought I had completed this problem before the video recorder cut me off, but I forgot to do domain and range. So let's talk about domain from left to right, all the places it might get interrupted. So coming in this way from negative infinity. So negative infinity to here at x equals -8. It gets interrupted here. It continues and gets interrupted again at -7. It goes on all this way till this next vertical asymptote at -2, and then keeps going. It gets interrupted at x equals 1, and then it goes on to positive infinity. And one thing I want to point out again is even though there's a horizontal asymptote right here, it's okay for the graph to cross through at small values of x, right? And we consider all of these on this graph small values of x. As x gets to very large positive infinity or very small negative infinity, the graph will come back towards the horizontal asymptote and never cross it again. All right, so a break at -8, a break at -7, -2, and 1. So we're going to write that down here as negative infinity to -8 union, -8 to -7 union, -7 to -2, -2 to 1, and then 1 to infinity right there. And then for our range, we want to look at the y values top to bottom. If there's any break anywhere, that there's not a point on the graph for a given y value. And really the only thing we need to check for here is this discontinuity. So at that y value, there's no point, but if I just keep going this way, there are two other y values that satisfy that point. So there is no break in the range. So the range is from negative infinity to positive infinity. Thank you. And then on this graph here, you'll see this is a new change. We have a slant asymptote here, but that doesn't overcomplicate the situation. We get our factor information from the roots, from the vertical asymptotes, from the discontinuities, and then we use a given point to find the a value. So we don't need to, this doesn't make the problem more complicated in any way. So looking at the graph here, I have 3 roots. One at -4, that would come from a factor of x plus 4. And you'll notice that it crosses through, it is not tangent, so that factor is not going to be squared. So I'm going to set up my general form equation here. So that factor is x plus 4. Then I have a root here at 5, 0. That would come from a factor of x minus 5. And it is not tangent there. It looks like it might be a little bit confusing, but you'll notice it dips below the axis and then comes up through the other root. So that does not need to be squared either. And then this final root is at 7, 0. That comes from a factor of x minus 7. And it's crossing through there from the bottom. It's not, so it's not tangent. And that factor I'll put here. All right, so then let's check out our vertical asymptotes for our denominators factors. We have one here at x equals -6, and it's at first it doesn't seem like we have another piece on this side, but if you notice this curve down here, if we were to extend this graph, what we'd have going on is this situation. So it is going apart on either side. It's going away, not together, so we do not need to square this factor, which happens to be x plus 6. So I'll put that in my denominator. me zoom out so we can see all of this. Right, x plus 6 down here. For this other vertical asymptote, at x equals 4, that comes from a factor of x minus 4. So we'll put that here. And again, the behavior is not together. It's away, it's not together. So we do not need to square that factor. We have two discontinuities, so two holes here. We just need the x value at those places. So this lower one on this one in the third quadrant right here. 1, 2, 3, that's x equals -3. That comes from a factored form of x plus 3. And remember, holes are where you have the same factor on top and bottom. So I'm going to place that there. And then this other discontinuity is at x equals -5. That comes from a factored form of x plus 5. And again, that will be the same factor on top and bottom. All right, so here is our general form. Now all we have left to do is solve for a. So we need a pretty point where we know the integer values to plug in, and the point that we have here is the y-intercept. That is at 0, -2, so that's my x and my y values. So I'm just going to plug those in, putting -2 in for my y, 0 for all the x's. Now I'm not going to write in 0 for all of them. I'm just going to go straight to the simplified version. So 0 plus 4 is 4. 0 minus 5, -5. 0 minus 7 is -7. Now, one thing I want you to realize is these that are going to be canceling, we don't need to consider those when we're plugging in because they'll just cancel out in the next step. So I'm not going to bother plugging 0 in for those x's. And then the denominator, 0 plus 6 is 6. 0 minus 4 is -4. So now let me see wherever I can simplify on the right-hand side. So 4 over -4 will give me -1, and that looks like about as good as it's going to get. So that leaves me, oh shoot, my thing has frozen. Let me pause this. Okay, and we are back. So I don't quite remember where it froze, but I have canceled out these 4s. They simplified to -1. So in my next step, I've got -2 equals positive, so a times positive 35 over -6. So to cancel that out on both sides, I'm just going to multiply by the reciprocal. -6 over 35, -6 over 35. So on the right-hand side, these cancel, leaving me a. And on the left, I have negative times negative is positive 12 over 35. So then to write my final equation, I'm just going to plug in 12 over 35 in for this a. Now, I like writing the 12 on top and the 35 on bottom. Technically, you could do one fraction in the numerator like that, but I'm not going to. So 12 over 35, and then all of the factors. Writing, writing, writing. Numbers, letters, numbers, letters. Parentheses. All right, 6 years later, we have an equation. All right, and now let's talk about the domain and the range. So coming in from -infinity, I have this portion of the graph for those x values getting me to this first asymptote. So I have a break at -6. I have a break at x equals -5, because if I go vertically up and down this line, There's no other x values there. Same thing with this discontinuity. That is a break at x equals -3. And then it picks up and it keeps going till the next asymptote at 4. And then after that, it goes on to infinity. So my domain looks like this. X is an element of, the first interval is -infinity to -6, union -6 to -5, the first discontinuity, union -5 to -3, the next discontinuity, union -3 to 4, the second asymptote, and then from 4 to infinity. And for the range, let's look at those y values. So I'm coming up from -infinity, scanning horizontally. Everywhere there's a y. So looking at this discontinuity right here, there's no y value at that point. And if I go out to infinity this way, there's never going to be a y value. So this is slant. So remember, this piece is going to go like this. So as I go out to positive infinity, the graph will never come back down here. And as I go out to negative infinity, I'll never have another piece of any graph with a y value out there either. So I know that there's a break right there. And I'm just going to estimate that y value. It looks like -1.25 or so. And then, so going up from there, just scanning left and right, everything's good, everything's good. When I get to this hole, this discontinuity, there's no y value there. So scanning left to right at that y value, I see that this piece of the graph does have a point there. So that is not a break at that y. And then it just keeps going up forever to positive infinity. So I only have this one break in the range. So my range is going to be y is an element -infinity to -1.25, union -1.25 to infinity. And that's the end of the lesson.